Okay, so let's do the simplest kind of mean value theorem problem, one in which basically you're trying to figure out if the mean value theorem applies in the first place, and then if it does, finding the value of C at which the IROC equals the AROC. So I've got two problems here, this yellow problem and this blue problem. So we're going to start with the yellow problem. So the first thing I'm going to do in here is I'm going to find the derivative. And of course, the square root of x is x to the 1/2, so the derivative of that would be 1/2 x to the negative 1/2 minus 1. And then because I'm going to be doing some math with this, I'm going to go ahead and write that as what it means. Now, when I look at this, I look at places where the derivative is undefined. Because remember, the function has to be differentiable over the interval in order for the mean value theorem to apply. So there is a place where this could be undefined. It's x equals 0. But if you look back at what we wrote in the mean value theorem, if an endpoint is non-differentiable, it's perfectly fine. It's only when an interior point is not that the mean value theorem wouldn't apply. And this is also continuous over the whole interval. So we're good to go on the mean value theorem. So with that in mind, I'm going to find the AROC, which is going to be f of 4 minus f of 0 all over 4 minus 0. Pretty sure f of 4 is negative 2 and f of 0 is 0, and it's going to be over 4. So that means my AROC is negative 1/2. So now, if I'm looking for the values of C at which the IROC equals the AROC, I'd take the derivative, I'd plug in the number C, the letter C, and set that equal to the AROC. So now, I'm just going to solve one equals 1. 1 equals C. And then I ask myself, is 1 in the interval from 0 to 4? It sure is. So this is my value at which the IROC equals the AROC. It's the value that satisfies the mean value theorem. Now it's possible, like we said before in the video before, to get more than one answer. It's also possible to get answers both in and out of the interval, but the only answers we ever care about are ones that land in the interval. Cool. Now, for the second problem, I'd start by taking the derivative. And again, because I'm going to be doing some math with this, I'm going to write that as what it means. And then, that's a 3 by the way, I ask myself, are the hypotheses of the mean value theorem satisfied? Is this function continuous and differentiable on the interval? So it's continuous. You can see that this would have basically no place where it's undefined in the interval. But when you talk about it being differentiable, when I look at the derivative, there's a value that can make this undefined. X can't be 0, right? Now, in the last part, the yellow problem, that 0 was not in the interior of the interval. It was one of the endpoints, so it was perfectly fine. But here, 0 is in the interior. This means the mean value theorem doesn't apply because the function is not differentiable over the interval. Now, that doesn't mean there couldn't be a place where the IROC equals the AROC. It just means that it's not guaranteed that there is one, and therefore the mean value theorem doesn't apply.